Welcome to Creating Virtual Machines Module 3. This is Lesson 1, Virtual Machine Concepts, Part 2. Now let's talk about virtual disks. A virtual machine usually has at least one virtual disk. Here we can see a representation of it. The virtual disk itself is stored on the data store, but in reality what's stored there are the virtual machine files that it's made up of. A couple notes, things to take note of. When you add your first virtual disk, this will implicitly add a virtual SCSI adapter to the virtual machine, which completes the connection between the virtual disk itself and the virtual machine. Again, you're going to have a minimum of one virtual disk per virtual machine, but it'll be composed of several files. The VMDK file, which is stored in the data store, that is a disk descriptor file. So that's going to assign disk size, where it's placed in the data store, and what kind of connection. Is it SCSI, SAS, etc. It also has information about the disk mode and even provisioning policies, which we'll take a look at later. Now the flat VMDK file, that holds the actual data. Now there may be more than one if the disk is split. Let's take a look at a couple of the options. Now we're going to talk about thick and thin provisioning of your virtual disks. Thick provisioning uses all the defined disk space at the creation of the virtual disk. So when you create your virtual machine and create the virtual disk, it's going to go ahead and set aside the total amount of space that you select for that virtual disk at the time of its creation. So that virtual machine disk will consume all of its capacity right at the beginning, as defined at the creation, regardless of the actual amount of data in the guest operating system file system. In fact, in most cases, the minimum requirements for your virtual disk will be far greater than the actual space consumed by the newly created file system. Here we can see a representation of 3 virtual machines on a host. Each one has a virtual disk. One is thick provisioned. That's a 20 gigabyte thick provisioned disk. Then you have a 40 gigabyte thin provisioned disk and an 80 gigabyte thin provisioned disk as well. You'll notice that on the 2 thin provisioned disks, they're only consuming 20 gigabytes of space on the second virtual machine and 40 gigabytes on the third virtual machine. So they're not actually using all of the space provisioned. Again, if we take a look at the first one, it has a 20 gigabyte thick provisioned disk, and it's actually consuming all of that space even if it doesn't need it. Now, let's take a look at 2 different ways that you can thick provision a virtual disk. You have both eager zeroed or lazy zeroed. And an eager zeroed thick provisioned virtual disk, every block is provisioned pre-filled with a 0. Every block is pre-filled with a 0. And on a lazy zero thick provision disk, it's only filled with the zeros when the data is written to the block, meaning that it acts like a thin provision disk initially, but as data is written to it over time, it's going to continue to write zeros on the blocks to fill them up. So let's take a look at an example. If you have 10 gigabytes of actual physical disk space, and you thick provision an 8 gigabyte virtual disk on the virtual machine, only 2 gigabytes will be available for use by other virtual machines. Now remember, it's in one of the things you want to be aware of, that this kind of thing is not recommended to use the thick, because although the virtual machine may grab 8 gigabytes when its operating system is installed, as mentioned earlier, upon loading it, you may only need 2 gigabytes. Therefore, those extra 6 gigabytes that were grabbed or allocated to the virtual machine are now going unused and wasted and may never actually get used. Again, with both the eager 0 and lazy 0, with both types, the space is set aside. But again, with a lazy 0, each block on the disk is only filled with a 0 at the time the data is written to the block. A downside of this is that some I/O latency can occur due to the 0 write activity on the busy disk, meaning that as the disk is being written to, part of that function is the overhead for writing the zeros to the block to hold that aside. So for a busy server like an Exchange database server where you may have quite a bit of writing to that database, this can put quite a bit of overhead as you're using it and can slow things down a little bit. However, say on a web server with static, web servers are fairly static. They don't change a whole lot. So actually using a lazy zeroed thick provisioning would be beneficial there. Again, you can use your eager 0 for servers that have a lot of write activity, such as an Exchange server, so you can write the zeros at the time that you provision it, and you will have less I/O latency. Let's take a look at thin provisioned virtual disks. Now, thin provisioning enables the virtual machines to use storage space as needed, meaning you're not pre-filling them with zeros. The virtual machine disks consume only the capacity needed to hold the current files. However, the virtual machine still sees the full allocated disk size at all times. And also, you can mix thick and thin formats on any virtual machine. You get full reporting and alerts that help you manage the allocations and capacity. One of the things you have to watch out for with thin provisioning is that if you thin provision, you may not actually have the space available on the actual physical disk if you're sharing it amongst multiple virtual machines. And you may end up running into a problem if you don't realize that's occurring.